Okay, class, where we are, we had brought the air down, and now we were looking at the vocal cords, and we were going to talk about sound. But before that, I had mentioned the difficulty of putting a tube into the windpipe, and that technique is called intubation. Now, if you notice here, you see, you can put a tube easily down. I'm going to come back to this picture. You can put a tube, if you did an NG tube, it would go straight down here. But it's harder to get into here. So to do intubation, you have to use this device here with a light at the tip and actually view the vocal cords. You can't go blindly like with an NG tube. And you're looking at these vocal cords, and you're holding the head like this, and then you take this tube, this intubation tube, and you see how it comes in here. See, here's the food pipe here. It comes in and lodges, then you blow it up. So I just wanted to show you the difficulty of doing that with the intubation versus just putting an NG tube in. Okay. Now we go, here are the vocal cords. The vocal cords are fibroelastic tissue. All right. The air comes from below. The air comes from below to vibrate these. Okay? So they're vibrating. That means waves. So we come here to waves, and we've mentioned this. A wave has a wavelength, an amplitude, how tall it is, and how fast it travels is frequency. Now, when it comes to speaking, the frequency of the movement of the cords, determines your pitch. So the frequency of the movement of the cords determines the pitch. The amplitude determines the volume. Now, in order to get a high pitch, then, you have to pull the vocal cords tight. Okay? Real tight. Now, however, if the vocal cords are thick and heavy, they can't vibrate as fast, so the person cannot get as higher pitch. Okay? Now, pretty much boys and girls have about the same size vocal cords prior to puberty. Close to. But at puberty, that androgen hits, that testosterone, and it starts to thicken the vocal cords. Well, who gets more testosterone? The male. So the male now, his voice will change all of a sudden in a way. Now here's the problem with this. It's almost like playing a guitar and knowing how far to put your fingers for the strings and how tight. The brain has learned what we call Broca's speech center and Wernicke's center. All these particular centers have learned how tight to make the vocal cords. But the thickness changed all of a sudden. So the young man, 12, 13, sometimes 11, sometimes 14, will be speaking, and all of a sudden his voice will go up and down because of that factor, because how quick these vocal cords are thickening. Okay? Now remember, the air to speak from comes below. You don't breathe it in, it comes from below. So that's just a little talk on these vocal cords here to kind of give you an idea. And remember, the false vocal cords probably keep the dust off of the true ones. All right, where do we go now? Let's go now, the air now. So let's go back to our original. So now we've gone through all of this. Now we're at the trachea. So we're following it down. Okay, at the trachea, this is what we're looking at. So here, right here is the trachea. Okay, that tube right there. Let's go down, let's go over here, see if we can't get something on the trachea on this one. All right, here we go. The trachea, a flexible mobile tube extended from the larynx into the mediastinum, about 4 inches long and about 3/4 inch wide, composed of 3 layers. A mucosa, which has goblet cells. The goblet cells produce the mucin, and a ciliated epithelium. It's a pseudo-stratified ciliated. Let me give that to you again, ladies and gentlemen. A pseudo-stratified ciliated. Then you have a submucosa, which is connective tissue. Then you have an adventitious made of C-shaped rings of hyaline cartilage. And actually the little adventitia covers those C-shaped rings. Those C-shaped rings. Okay. Now I'm going to come down here. So here would be a cross section of the trachea there. Now I want to show you. These are these C-shaped rings. And the reason they're C-shaped is because if they were fully going around, they would bump into the esophagus. So by keeping them C-shaped, you don't bump into the esophagus. Then you have this trachealis muscle. That's the muscle that can contract and so forth in some conditions. It can close the airway off or dilate the airway and so forth. That trachealis muscle. Okay? Smooth muscle. All right, here's that submucosa. That's the, the epithelium there on the surface. They're pseudostratified ciliated. Now the cartilage. Okay, what I want to bring to you now is this. Collapsing pressure. The term collapsing pressure. Because the lumen of these pipes has water. Everything has to have water with it dry out. And water has what we call a surface tension we're going to talk about. The pipes would collapse. The faster the flow of air, the more the collapsing pressure. Let me say it again to you. The faster the flow of air, the more the collapsing pressure, dealing with the surface tension of water. So in the larger airways, which are going to have a lot of air coming in, shall we say, a lot of air coming in, then you need more cartilage to support it. But what's going to happen as we go further down and it gets smaller, you won't have as much flow. So then all of a sudden the cartilage is going to there'll be less and less cartilage, shall I say. Then finally you'll get to the point where it's so small that you still need something to stiffen up the wall, but you don't need cartilage. You'll replace that with muscle. And that's when we get into the bronchioles. So see, the faster the flow, the more cartilage. The slower the flow, the less cartilage to keep the walls open, and finally get to a point it's small enough where you still need to keep the walls open, but you can use something else. Okay? You don't have to use the cartilage. All right. And we'll talk about that's when we get to the bronchioles. Okay? We'll talk about that. All right, here's an example of a bronchiole. I'm not interested in that. So you remember we mentioned that the things start to thin out as we go to try to get to a good diffusion. So we come back over here. Here's the trachea again. Here's that picture there we talked about. We already talked about that there. Okay, now the conducting zone. We're still in the conducting zone now. Remember, see, right? Let's go back up. We're still in the conducting zone. Okay, we're in the bronchi. All right, so I'm going to come down here. Carina, last trachea marks the end. I'm going to come down. I'm going to explain this right here. Air passage can undergo 23. Some will say 28. Remember I mentioned? Okay, I'm going to come down here, and we're going to do this. Okay, now I'm coming down right here, right before I go into the primary bronchi. And right here inside the trachea is an area called the carina. Now let me explain what that is. It's like, but it's inside the trachea, an area called the carina. The carina is the last area that can stimulate the cough reflex. Let me say that again to you. The carina, which would be inside the trachea, is the last area that can stimulate the cough reflex. It's a cough-sensitive area. Now, it's the mucosa of the carina. It's the mucosa of the carina. Rationale: cough is to clear stuff. Cough is to clear stuff. To really clear stuff, you need both airbags. To clear stuff, you need both airbags. So this is the last time before you split into one airbag or the other. So there's no point in putting it further down because one airbag could rarely discharge anything. So inside the trachea, if we were coming down, the carina would be the last area of the cough reflex center. The last area. Okay? And that would be the carina. Then from there, where we're going are here, into here, which would be the main stem bronchi. Okay? I think I'm going to end right here and start with the main stem bronchi as we go into that. Okay?